So let's take a look at the redundancy. Okay. What does redundancy allows the ability to do? Redundancy gives you access at different levels. You can get redundancy at the port level. You can get redundancy at the box level. My objective today is going to take a look at redundancy at the interface level. What do I mean by that? Let's say this is my topology over here. This is my firewall going to my outside router, which connects me to the internet. And I have my inside network, which goes to my inside devices. What happens if this cable or this port goes out? I have a single point of failure. Agree? Yeah? So, yeah, you might say, well, I also have a device level failure. Absolutely. We'll take a look at that when we talk about failover. But for right now, the first level of redundancy I want to provide is the ability to provide redundancy at the interface level. There are two options that I have for that. Option number one, what I can do is I can bundle the two interfaces as a single logical interface. Known as a redundant interface. This technology has been there with ASA for a while now. The problem or the shortcoming of this technology, the redundant interface technology, although the two interfaces are bundled in as a single logical interface, only one of them is forwarding at a time. Like STP, very true. So all it's doing is providing redundancy. It is not providing any type of bandwidth aggregation like a port channel. This is not a port channel. Initially till 8.3 iOS, this was the only interface redundancy capability that you had on the ASA. In 8.4, they introduced the ability to connect up this as a bundle, but with a port channel capability. So you could actually create a port channel on the firewall with the switch. What does a port channel give you the capability of doing? It gives you redundancy and load balancing. So in that manner, if this link goes down, the other one's still there. When both are up, both are forwarding towards the switch, which in turn connects up to the router. Nowadays, nobody's going to use redundant interfaces because it does not give you the same capabilities like a port channel, but you need to understand in terms of history, this used to exist before port channels were there. So at that time, you didn't have a choice but to use redundant interfaces. You understand that? Today, most of the people are not using redundant interfaces unless it's been configured and they don't want to change it. Otherwise, everybody's using port channels right now on the firewalls. Clear so far? What I'm going to do is I'm going to use the same topology to do that for you guys. I just need to find out where it's at. So I'll stop this lab. Okay. Yep, this is the one. That'll come up. I'll also bring up the diagrams for you guys. I'll put it into your folder. Okay, this is your physical topology over here. Later, let's finish this up and then we'll talk about those things later. So this is my physical topology over here. I have a switch connecting to the ASA. This is acting as my outside network. What I'll do is, to show you both in the same places, in the same topology, what I'm going to do is, I'm going to create a port channel with switch 1 on the outside. On the inside, I'm going to show you how to do it as a redundant interface where the ASA connects up to the switch. The switch in turn connects up to the internal devices. I'm showing you a router over here so that we can test it out. So this is the way the logical topology will look like. This is the actual physical cables, which are not going into this line. They're going into a switch. Everybody okay with this? Yeah? So let's do this. Let's bring it up. I think I need a 6. Oh yeah, I only have one ASA. Yeah, sorry. So this is my ASA. This is switch 1, which is on the outside, switch 2 on the inside. I'm going to use switch 2 first, which is on the inside for my, redundant interface. So how do I do it? Let's go to router 1 and check what I have on router 1. I have an IP address assigned 10.11.11.1, show IP route, and I have a default gateway pointing to 10.11.11.10. So this interface over here, this redundant interface, will have an IP address assigned to it as .10. Good so far, guys? So E2 and E3 on the ASA will act as my inside interface. But I want to combine them into a single logical unit of 2 and 3 as a redundant interface. Okay, I'll show you the config on the ASA and the corresponding config on the switch. Okay, so on the switch, if you guys think about it, all these 3 devices, logically, all these 3 ports are in the same VLAN. Do you guys agree? Because I need this port, which is redundant 1, which is made up of these, all these 2 ports, and the switch port need to be in VLAN 10 on the switch. You guys agree? Yeah? So let's do that. On the switch side, E00, 01, 02 should be in the same VLAN. So I'll do that over here. Config T, interface range, E0/0-2, switch port mode access, switch port access VLAN 10. So as you guys can see over here, these three ports are part of VLAN 10. Out of these 3 ports, 00 and 01 are connected to my redundant interface towards the firewall. E02 is towards my router. I want all of them to be in the same VLAN. So my switch configuration is done. How do I configure the redundant interface? The first thing that I do in terms of the redundant interface is bring up the physical interfaces. I need to no-shut the interfaces. So I'll say E2, no shut. E3, no shut. Simple enough. So if you take a look at my interface IP brief, you'll see that these 2 interfaces, which are going to act as my redundant interface, are up and running. Good, guys? Everybody okay with this? So my first job to create the redundant interface. Oh, I have to put the NAT statement. Let me put the NAT statement for you guys first. NAT inside, outside. source static C1, change it to X1 when the destination static is D1, D1, D2, D2, C1, change it to X2. So now let's do interface redundancy. Okay, allows you to connect two interfaces logically as one, not two through 8. You can have up to 8 physical interfaces act as one. Although you have bundled 8 interfaces, only one will be forwarding at any given time. Okay, so the way you do it, on the switch, assign the ports to the same internal VLAN. So in my case, I did it on switch 2, interface range E0/0-2, switch port mode access, switch port access VLAN 10. All right. Now the next thing, configure the redundant interface on the ASA. How do I do it? Step 1, bring the interfaces up. I would say bring the physical interfaces up. How did I do that? E2, no shut, interface E3, no shut. Good so far, guys? Everybody okay with this? Now that I've done that, create the redundant interface by specifying the member interfaces. What are the member interfaces for this redundant interface? E2 and E3. So the way you do that, interface redundant and a number, member interface E2, member interface E3. Because they're two physical devices, they will use the MAC address, and then you would need to do the gratuitous ARP in case one goes down. It's recommended that you do what? Assign a virtual MAC address. Not required, recommended. Okay? At this point, configure a virtual MAC. Configure the interface with the nameif security level IP address normally. So when you do the configuration, what you used to do on the physical interface, you don't do it over there, you do it over here. Nameif inside, which would set the security level to 100, IP address 10.11.11.10, no shut. Do you guys notice what I did? I did all the normal configuration that I normally would do where? Under the physical interface, I did it under the redundant. And the redundant interface has these two member interfaces. So the traffic will go under either one. The first one is the one that gets activated by default. So let's just paste this and see what happens. Show interface IP brief. Notice redundant 1 is up. It has an IP address of 10.11.11.10. If you check the redundant interface itself, you will notice that one of the ones that is active is the first one. The other one is not active. Can I ping? should be able to ping 10, 11, 11, 1. If I go on R1 and I check my ARP, you'll notice that address, the virtual MAC address that I assigned it, that's what it's using, regardless of it's E2 or E3. Clear, guys? Simple enough, very simple way of doing it. Now you don't even need to reference redundant one, because any command that you would do it based on the name if command. Right? For example, let's say R1 over here has a loopback. Okay, and I want the ASA to be able to route to it. So how would I do it? I don't point to the redundant interface. I say route inside, which is already assigned to the redundant one interface. 10.1.1.0. Next hop is 10.11.11.1. So you can ping 10.1.1.1 now without a problem. Yeah, see that? So I'm not referencing the redundant interface from this point on. I reference the word inside, just like I've been doing all along. Everybody okay with the redundant interface? Very simple to do. What's the drawback? Only one forwarding.